Hi all. Today we are going to discuss a confusing concept in Apache Kafka, which is consumer group. So let's consider this is Kafka cluster. So you have multiple machines in which this Kafka is installed. So let's say there are four different machines or four different servers or four different nodes. You can call it with any name. In Kafka, we call server as broker. So let's say there are four brokers, B1, B2, B3, and B4. And we'll take an example of any e-commerce application like Amazon or Flipkart, and we'll take a use case of order creation. So let's say there is an e-commerce ordering app. So this is ordering API. So this ordering API receives all the requests related to orders and they create the order. Once the order is created, it will insert this order creation event or message into the Kafka cluster. So here the order API is the producer. It will, whenever any order is created in the ordering application, it will insert into the Kafka. Here there will be consumers, so who will consume every event related to order creation, order placed, and then it will do the necessary activity. For example, I'll take two consumers. So one is probably notification API. This is one consumer. So as you know, notification means sending SMS and email to the customers. So for every order created, this API will read that message and then send SMS and email to customer saying your order has been placed successfully. So the other one can be payment API. So for every order placed, it will take care of the payment. So let's consider these two applications needs the order placed event so that they can act accordingly. Now let's say we'll create a topic for this. The topic name is order placed. So in Kafka, we'll create a topic called order placed, and ordering API will insert messages into order placed topic, and notification API and payment API will read messages from the order placed topic. So that is how it works. In Kafka, we have a provision to distribute the load. Let's say there are 3 million orders coming. Uh, Orders will be written, messages will be written into Kafka. So we need not to store all the 3 million into one server or one broker. We can distribute that load. Kafka has given us that provision. So that means the order placed topic can be created in multiple brokers. So order placed topic is, let's say for in this case, we'll consider the order placed topic is stored in three different brokers. That means, for example, 1 million orders will go here, 1 million will go here, 1 million will go here. So the 3 million load is distributed among multiple brokers. So I will call this as, in Kafka, this, when we break messages into or the topic into multiple parts, each one we call it as a partition. So let's say this is partition 1 of order placed topic, this is partition 2, and this is partition 3 of order placed topic. So this is how it works with respect to the partitioning. Now notification API has started reading all the messages. So what are the steps involved at notification API? It will first read all the messages from P1, then it will read all the messages from P2 partition, and it will read all the messages from P3 partition. So finally it has read all the 3 million messages for the order placed topic. So let's consider it takes 10 minutes to read all the messages from each partition. In total, will take 30 minutes to read all the messages from order placed topic across all the partitions, correct? So but this is not optimal. Why we are taking so much time? Instead, what we can do, we can read from each server parallelly. So what are the ways to read it parallelly? So in the notification API, probably we can create three different threads, and then we can read, each thread can read data from each partition separately in parallel. That is one way. And the other easier way is, maybe we can run the notification API itself. That program we can run multiple times. So we'll call them as instances. So we create three instances of the same notification app. Probably we can run in three different servers or three different nodes. You can call it as three different virtual machines or three different pods or containers. So the same application will be run in three different instances. Now all three will read the data from all these three partitions in parallel. So now we'll take the notification API. So this is notification API. We have instance 1, instance 2 and instance 3 want to read all the messages. So how they read it? They will make a request to Kafka saying, hey Kafka, I want order place topic, all the messages from this topic. Can you give me any partition name from where I can read all the messages? Then Kafka will see it finds out that okay, this order place topic is present in three different brokers and three different partitions. Let me assign one broker and one partition. So let's say it has assigned P1 partition to the instance 1. So I1 will read all the messages from this server. So I1 has processed, the processing of I1 has completed. I mean, it has started. So then the instance 2 also requests Kafka saying, okay, for order placed topic, can you give me any partition? So then Kafka will check again who are all which all partitions are available for this topic. Again, P1, P2, and P3. It randomly gives any partition. It is quite possible that it may give the same partition again. Same with I3 also. The Kafka may give the same partition again. So if you see, there is a problem here. Kafka is giving the same partition for all the instances. So all three instances are reading the messages from the same. So each order will be read 3 times by this. So it's a duplicate thing. So that means for one order, let's say we want to send an email to customer saying your order has been successful. Now the customer will receive 3 emails for the same order, which is wrong. So we should never process the same message multiple times, correct? So to resolve this issue, we have a concept called consumer group. In consumer group, how Kafka works is every application has to come up with a consumer group name. So let's say notification application has created one consumer group called notification consumer group. So in short, I will call it as NCZ. So while requesting, instance 1 will say that I want messages of order place topic and I belong to notification consumer group. It will say that it belongs to which group. Then what Kafka will do? Kafka will maintain this mapping in its memory. So how it stores? It will store that okay, I1 instance of notification consumer group, I will assign partition 1 to it. So then we get partition 1. Now when instance 2 starts and it requests Kafka instead of directly giving one of the partitions, it will first check in this table. Okay, for an instance belong to notification consumer group, already we assigned P1, so we should not assign P1 anymore. We should give either P2 or P3. For example, it has given P3 for instance 2 from the same group. So now we get P3 here instead of P1. Likewise, for the third instance, obviously only one is left, which is P2. So it will give P2 to the third instance. Let's say if you start one more instance, I4. So what happens? Kafka will check all the three partitions have been assigned to three different instances of the same group. As I4 also belong to the same NCZ, so it says that you have to wait. So it will wait in the queue until one of these has been released. It cannot give any other partition to this because all the three partitions were given to three instances. So there is no partition available to give it to fourth instance. So now in this way, if three part instances are running in parallel, each will take 10 minutes in parallel. So total time by which it can read all the 3 million messages is just 10 minutes. So this is the optimal way of reading messages. Same way how we have done it for notification API, we'll do it for payment API also. Here also we will create a payment consumer group. So same way here also when multiple instances of payment consumer group request, it will assign a partition to it. Same way how it worked for notification API, we'll do it for payment consumer group as well. So this is how partitioning and consumer groups work in Kafka. I hope you understand it. Thank you very much.